The Byzantine general's problem explores how to prevent fraud and establish consensus in a distributed environment. Picture this. 4 generals and each of their armies surround a city they wish to conquer. The 4 groups are separated geographically and can only communicate via courier. The group must establish a course of action. Do they attack or retreat? In order to be successful at either, they must communicate via the couriers, reach a consensus, and all perform the decided upon action at the same time, or they face certain defeat. However, one general is actually a traitor for an opposing army and is tampering with the messages, hindering a consensus. There is also the issue of couriers being intercepted and their messages being changed. There is a similar issue in a distributed environment like blockchain. How does the network establish consensus when a new block is added? The generals work around this problem by encrypting their messages in such a way that they cannot be tampered with. They embed the previous general's message into their own and only have a short, set period of time to send it, let's say 10 minutes. So in order to tamper with the message, they would have to spend 10 minutes creating their own new message, and then spend another 10 minutes recreating each of the messages of everyone before them. However, because this whole process would take longer than 10 minutes in total, their message would be rejected by the other generals. Blockchain similarly uses encryption methods to protect authenticity. One common method is a proof of work. However, there is also a proof of stake and other ways to establish consensus. A proof of work is a protocol that each new block is asked to perform. The protocol is time-consuming and difficult to perform, but easy for others in the network to verify. The protocol requires each new block to encrypt their message, create a unique and valid hash, and embed the hash of the previous block into their own. For Bitcoin, this takes about 10 minutes. Other blockchains will have different time limits. If the process takes longer than the set amount of time, it will be rejected by everyone in the network. In order to commit fraud or tamper with any block, a hacker would have to create their own block, tamper with the hashes of every other block in the chain, and replicate this on at least 51% of the nodes in the network, all in the short set time limit. Highly improbable. So, what does this mean? This means for the first time in the history of computer science, we now have a technological invention that makes it possible for a distributed network of thousands of nodes, or our 4 generals, to reach a consensus about every transaction, record the details, and make those records almost mathematically impossible to forge.